Are you having trouble with implicit differentiation? Well, fear not, because in this video you're going to know what implicit differentiation is, how to solve it, and knowing when to use it in a problem. Alright, so let's get started.
Okay, so what is implicit differentiation? It's just differentiation with respect to x. You guys should already know what differentiation is, but just in case you forgot, we're going to do a problem. Alright, here it is. Alright, I'm going to give you guys a few seconds to figure it out, and then I'll solve it out for you. Alright, so let's do this. We all know that the derivative of y is dy over dx. And then we derive these two numbers, and that'll be our answer. Or you can simplify it more, so it could become either answer is fine, since they're both basically the same thing. Alright?
Okay, so hopefully you guys got that answer. So let's get back with the definition of implicit differentiation. So the problem that you guys have answered is differentiation. Well, implicit differentiation takes it a step further by adding more into the problem. Okay, it doesn't make sense, but alright, so let me give you a problem. Coolios. Alright, so try to solve this. Alright, see how this was different from the last problem? Well, let me give you guys a few seconds to solve it out, and I'll solve it out right after that. Cool? Alright, so let's do this, shall we? Alright, so first of all, we have to derive this whole equation, both sides. So the derivative of 2x would be 2 plus the derivative of 4y squared is 8y. Don't forget y prime, which equals 0, because the derivative of 16 is 0. And you guys are probably wondering what that y prime is. That's basically this. That's y prime. It's just another way to write it out. Cool? Alright, so now we have to leave that y prime by itself. Alright, so we subtract 2 on both sides. Negative 2. Alright, now we factor out the y prime. Negative 2. So now to leave it by itself, we just divide by 8y, which will get us negative 2 over 8y, which you could simplify it into negative 1 over 4y. Alright, so do you guys get it? Alright, it's cool. We'll just do a few more problems. But first of all, I want to talk about explicit and implicit. Well, up to now, you guys have been doing explicit, which is like problems like y equals 2x plus 1, and you have to derive it. These are explicit differentiable problems. Implicit just takes it a step further, like the problem we just did. Which is something like that, which is a little hard to solve, but it's solvable. All right. Okay, so to help you guys with the implicit differentiation, I come up with a way to ease out this pain of deriving these equations. Okay, that didn't make sense, but okay. So here's the acronym. DOFS. D means to derive. O is to organize. F is to factor. S is to solve. Okay, so let's start with derive. So you're basically deriving both sides of the equation. All right. O, you're organizing your equation.
You're organizing your equation, because when you derive both sides of your problem, say like y squared x to the fifth, you will most likely, let's put an x in there. You will most likely have, okay, wait. All right, so because if you derive both sides of your equation, you will have y primes and other numbers and variables. So what you're going to do is that you're going to put all the y primes on one side. So you're gonna have y primes here and other variables here. All right. Okay. So f factor. So factor out your y prime, because most likely your y prime will not be alone. It would be with an x or another number. So what you're going to do is just factor out the y prime. Like this, for example, 4x y prime, you will have y prime times 4x. All right, so you're just going to factor out the y prime. Then you solve the equation. So you solve for y prime, and there we go. That's DOFs. All right, so let's get into some problems. Yay. So now try this one. X cubed y cubed minus y, which is equal to x. I want to okay, first try to solve this out. This will be challenging, but and I'll give you a few seconds to solve it. And I'm gonna give you a hint after those few seconds. All right? Okay. So do you guys know what you have to do here? It's the same as differentiation. You have to use the product rule. I'm pretty sure you guys remember how to do that. So that's what you have to do here. Sweet. So this may be challenging. So let's still derive this. All right. So the derivative of x cubed to the y cubed, the derivative of x cubed times y cubed is equal to 3x. Let's put it in brackets so we won't confuse ourselves. It should be x cubed times 3y squared times y prime. Remember, because this is also a chain rule, because you still have the y's in there, so y prime. So there's that, plus y cubed times 3x squared. So this is the derivative of that, minus y prime, which is that derivative, equals to 1. Alrighty then. So if you remember DOFs, we just did D, which is to derive both sides. Now we use O. We have to organize all this. So we have to get all the y primes on one side and all the others on the other side. So first, let's simplify this so we can have a little more room. This will be squared, let's change that to x cubed, y squared to the y prime, plus 3x squared y cubed minus y prime equal to 1. So we have to get all the y primes on one side and all the other variables to the other. So we subtract the 3x squared y cubed to the other side, which will get us 1 minus 3x squared y cubed. So now that we have y primes on both sides, we go to our